everybody, and welcome to the Saratoga County History Center and our presentation of sundials and the summer solstice. I'd like to actually ask, how many people are members here? Excellent. Thank you so much for your support. I have to say that from 4 years ago, when we almost had to close this building, to now, when we actually have almost packed rooms every time, that's phenomenal, and we couldn't do it without your support. So thank you very much. And if you haven't thought about becoming a member, please stop at the front desk and check it out. You know, it's a pretty great group of people, and we have a lot going on. We have some upcoming programs on this sheet on the way out. We have a Frederick Douglass impersonator coming at the end of July. We have walking tours throughout the summer. We have garden talks out here that are fantastic. And we have a couple music programs coming up. So, and you can also get on our email list if you'd like. And you get a couple emails a week to just keep you in the loop as to everything that's going on here. Thank you very much for coming tonight. And without further ado, here is Steve Williams. He's a local author, and we actually sell his book here. So check that out. And he's here to introduce the program tonight. So thank you very much.
Yeah, thank you, William, and thank you for everybody who's here tonight. You remember a few years back there was a beer ad campaign? He's the most interesting man in the world. I'm not here to introduce the most interesting man in the world, but he may be the most interesting man that I know. He's a friend and he's a neighbor, Jere Blackwelder. He'll be up here in a minute. Jere grew up in Atlanta. He came north to the University of Pennsylvania for college. I've been trying to practice University of Pennsylvania all day. It is much easier just to say Penn. That's where he met his wife, a Schenectady GE brat named Julia Kirk. I was worried about offending Julia with that, but she's not here. So, yes, he married a GE brat. And they have been married for 60 years as of last week. Yeah, if you've ever been married, that's worth it. They have 2 grown children. Jere at Penn studied political science. He thought enough about becoming a lawyer to have taken the LSAT. And he did reasonably well, but money was a problem. So we did not have a lawyer, Jere Blackwelder. He began his work life selling engineering supplies. Julia became a professor of history, and he followed her when she took a job in Charlotte. And again, when she took a position at Texas A&M. He's done a lot of things in his life. He has worked for Habitat for Humanity. He has started a brewery. Jere can speak from experience when he says, college kids don't want good beer. They want cheap beer. He's been a member of 3 different Rotary clubs and a president of 2. Since he was used to moving wherever Julia said he should go, we shouldn't be surprised that when she retired from teaching and wanted to return to her Capital Region roots, he followed. Here, he's been not just a Rotarian in Ballsont Spa, but a director of the Ballsont Spa Business and Professional Association, manager of the Ballsont Spa Farmers Market, a director and former president of the Saratoga County History Center. And what William was saying about this building and the organization nearly closing 4 years ago, Jere was instrumental in the turnaround that we had seen since then. And they did it all while we were under COVID. With all the different things he's done, you might think that he'd have very little time left to think. Well, think again. Because Jere is here tonight to talk about sundials and about time. Ladies and gentlemen, I give you Jere Blackwelder.
Howdy. That's not good enough. We can do better than that. Back where I come from, if somebody says howdy, you're supposed to say howdy back. Howdy. Howdy. There we go. That's much better. Steve, thank you for that introduction. I don't know who that fellow is, but I sort of think I might want to meet him. And I'm a good notion just to sit down and ask you to do it over again, because I don't get those accolades very often. Matter of fact, that's the second best introduction I've had in a long, long time. The first was years ago. I was in Charlotte, North Carolina, and I was speaking to a bunch of Shriners about zoning. And the fella that was supposed to introduce me didn't show up, so I had to introduce myself. Now, that was an introduction. I think sundials are nice. And if I pull this off tonight, I'll have you as a believer as well. And to do that, we're going to talk about a lot of little tidbits of history and timekeeping and try to fit this whole thing together and put it in perspective. What was it Lewis Carroll said? The time has come, the walrus said, to speak of many things, of ships and shoes and sealing wax, cabbages and kings. And that's what we're going to do tonight. We're going to talk about all those kind of things. And we're not really going to be discussing what is time, because the mathematicians and the physicists and the poets and the philosophers can't agree on it. We're just going to have to treat time as ordinary mortal people. And it's been going on, a concept of time for who knows how long, because all ancient societies had to be cognizant of the fact that it's daylight, it's night, the shadows are long, the shadows are short, the seasons come, and the year, as the sun rises and the sun sets, there's a concept there that time exists. And for those that started civilizations, agriculture probably helped move that along. And when agriculture started by women, and it was certainly by women, men were out hunting down saber-toothed tigers and mammoths, you had to have some way of measuring inventories, whose property is where, how much did you produce, and taxes. And I think that's where numbers came in first. They had to have a concept and discover numbers in order to tax you. I'm pretty well convinced that's the case. The Sumerian mathematics started long before the writing did. They finally did. I'm going to have to do this manually. That's their series of counting. It's a base 60. In other words, they count from 1 to 60 before they go over with. We count to 1 to 10, then we start over and get them 11. They went 1 to 60. And they didn't write it down. This is much later. It appears that the Sumerians in Mesopotamia counted with their hands. If you look at your hand, you've got 3 knuckles on each finger, and you got 4 fingers. That's 12. You got 1, 2, 3, 4, 5. 5 times 12 is 60. There's your pointer. So if you wanted to add, and you can imagine, it takes a little practice, but it would come to you in short order. You could put a thumb on the knuckle there, and that'd be one number, and you could add it to this other number, and come up with this number, and keep the count on the other hand. And they did. They counted on their hands long before they started writing. A 60 sexadecimal, I think the mathematicians call it. And it's not a bad idea, because as it worked with your hands, but it also worked because there are a lot of fractions you can do with 60 that you can't do with 10. Why am I telling you all of this stuff? Because, folks, we still use that system. There's 60 minutes in an hour. There's 60 seconds in a minute. A circle has 360 degrees. Nothing's changed. Well, you know, we use a decimal system now, 10, but we still use things that were done 10,000 years ago. All great civilizations thus far, there's no reason to think it's going to be otherwise, generally come to an untimely ending. And in this case, the Sumerians were conquered by the Babylonians. You can read right there in Genesis. And the Babylonians took on that base 60 numbering system, expanded it, and did some fancy calculations. Those are, somebody said, are Pythagorean theories, square of A plus square of B equals the square of C, and they use that for surveying. I can't vouch for that. But they sort of slowed down that 60 to just enough to give us forever, as there are 12 hours of daylight and 12 hours of darkness. That's the Babylonian concept right there. They moved it from 60 to 12. And of course they did a lot of other things in 12, and so do we. We still order a dozen cookies, a dozen eggs. There are 12 inches in a foot. We're doing things just like the Babylonians did, like the Sumerians did. It didn't change much. The Babylonians, though, like the Sumerians before them, they got conquered by Egypt. Egypt had a numbering system as well. It was different from both of them. It was sort of rudimentary base 10. But they accepted the Babylonian idea that there was going to be 12 hours of daylight and 12 hours of evening, and you start counting them at the evening. Here we have the very first sundial to measure the 12 hours of daylight. And it's in the British Museum, but I made a copy of it. That's all it is. It's got 6 o'clock, 5 o'clock, 4 o'clock, 10, 9, 8, 7. It's just like that. And if I can find my... There you go. Here's how it worked. Sun comes up in the east, and it comes at a very slim angle, and there it is, 6 o'clock. And as it comes up, that light's going to come to 7, 8, 9, 10, 11. And when it's right overhead, it's going to be noon. You've measured the hours of morning. Well, what about the afternoon? Not to worry. Turn it around. And the sun keeps going, and it slides down until, it reads 3, 4, 5, 6 o'clock. That's all. The original is stone. And this one's a piece of junk wood, but that's all there is to it. And I read somewhere, and I don't know if it's a fact, that it was still in use in parts of Egypt as far as the 18th century. Pretty remarkable. Let's take a peek at it at 12. Where am I? Okay, Egypt stays around a long time, built pyramids and civilization for a long time. But the Greeks conquered Egypt. And they moved in, and let's see if we can. There's that Egyptian sundial, noon, 5th hour, 4th hour. There's the Greek sundial. It's got a curve in it generally, and they line up the lines equally so that you can tell the time. Now, what's interesting about the Egyptian sundial and the Greek sundial, and later on the Roman sundial and some others, is that they're called seasonal hours, temporary hours. It's an hour, the day is divided in 12 sections. So in the summer, when you've got a lot of daylight, the hours are further apart. In the winter, when the sun is low, everything's tightened up and you've got hours that are shorter. That didn't make much difference in Egypt because it's pretty close to the tropical Capricorn. But if you went to a place like London, for instance, your winter hours would be 37, 38 minutes. Your summer hours could be 85, 88 minutes. And that's a big difference. And it's an important difference in that we've got to understand how folks thought about those hours. And I've come to the conclusion that it was a process of most folks were out in the fields working, and they really didn't care whether the summer hours were shorter or longer. It was just, you had to put in those hours. Noon, top of the sun, that would always be noon, would break the day in half, and you're halfway through whatever you were doing. Let's see if we can get, no, I've gone too far. Rome conquered Greece. And it took them a while to do it. But they adopted a lot of things, including the sundials. And Rome soon was full of sundials. It was so full that Plautus, a poet and playwright, about 250 BC, wrote a poem. And if you can't see it, I'll read it to you. The gods confound the man who first found out how to distinguish hours. Confound him too, who in this place set up a sundial to cut and hack my days so wretchedly into small portions. When I was a boy, my belly was my sundial. One more sure, truer, and more exact than any of those sundials. The dial told me when it was time to go to dinner, if I had anything to eat. But nowadays, why, even when I have, I can't fall into unless the sun gives leave. This town is so full of these confounded dials. People didn't want the time regulated. Now, riding over here this evening, I got to thinking, what would Plautus have said if he had to deal with one of these things? I understand now why his anguish is that we're slaves to those kind of things. It's the end of Rome, 476 AD. Rome's fallen. And nothing really has changed. We have seasonal hours on dials of various shapes. But the most that anyone is asking for is a noon dial, and that's a noon marker. Got a little hole in that wheel there, and when it falls on the total vertical on that wall, it'll shine as you see the image there, and that's solar noon. And those stayed around a long time, even after clocks came in, because that's where you set your clock. You waited for the sundial to tell you how to do it. But put your mind to it and think about Rome has fallen, the greatest civilization ever existed. It's going to be 1,000 years before the Renaissance comes. History books call it the Dark Ages. 1,000 years. And how do we get from Roman times into the Renaissance and modern times? And several things have got to happen. Number one, we got to get rid of Roman numerals. Think about how you multiply XCLLV times XIV CLDV. I mean, throw your hands up. Truthfully, it can be done. When the pandemic came, I started trying to do that, and it's a waste of time. Roman numerals are fine for monuments and tombstones, but they won't work for mathematics. So we got to solve that problem. And the other problem we got to solve, well, two of them. One of them is to get a zero into our mathematics. That concept of a zero is going to be important for higher mathematics and algebra. The other thing we got to do is we're going to have to find out convincingly and do some convincing that the earth is not the center of the universe. Church is saying that this is it. And we're going to prove that. Well, let's tackle the Roman numeral problem. When Rome fell, a couple hundred years later, Islam started, and it was a powerful religion. It just took over North Africa and the Levant and the Mideast. The center of learning was no longer Rome or Greece. It was Persia. And they had some mathematicians that preserved the concepts of mathematics that really were lost when we went into the Dark Ages. Among them was Arabic numbers. Now, I know there's a cartoon in Times Union the other day about trying to multiply Roman numerals because some parent had objected to Arabic numerals in the classroom. But it does work. Arabic numbers, and add that zero, which they got from the Hindus, which gave them to the Persians. That's a Hindu invention of zero. Mathematics could take off, and it did in the 8th, 9th, and 10th century. Unbeknownst to the Europeans, we were in the Dark Ages, but they were formulating some mathematics and solving that problem of how you multiply and divide and do algebra and higher mathematics. It drifted into Western civilization in the 1300s and 1400s. The other problem about the Earth being the center of the universe took a little longer. But I'm going to lose some slides here if I don't flip some. We'll come to that one. The 1476, I believe it was, before Columbus, but not much before Columbus, a fellow by the name of Copernicus, a Polish priest, matter of fact, got interested in astronomy, and he spent 20 years charting the skies. Now, he had no telescope. He was just charting the skies as they went through. And the interesting thing about the movable stars, we call them planets nowadays, but in those days they call them movable stars, is that sometimes they went this way and sometimes they went that way. And he says, this is not right. So he put a model out in his head after 20 years of writing all this stuff down that said, if you use the sun instead of the earth as the center, everything works. They're all in concentric circles. And I'm going to publish that. Well, there's two ways of publishing something like that if you're going to deal with church. One is to publish in Arabic, which you didn't know. And the other is to put a disclaimer on it. And sure enough, Copernicus publishes this book, it spread like wildfire. But the flyleaf on it says, note from the publisher, the things that are written about in this book may not be true. And he got away with it that time. A century later, Johannes Kepler, German scientist, mathematician, expanded on Copernicus' work. And what he said was, whoa, there are things here that we just haven't thought about in this sun-centered work. And he published Kepler's 3 laws of astronomy. You probably studied them in general science. I know I did and forgot them the next day. The first one says the planets, the movable stars, don't circulate around the sun in a circle. It's an ellipse. And one of the focuses of that ellipse is going to be the sun. So they're moving around in sort of an ellipse shape, not an oval shape. Kepler's second law says if you add up all the distances that the planets travel, they travel faster when they're close to the sun and slower when they're further away. And you can visualize the ellipse and see how this would be true. They don't travel uniformly. Now, by this time, Sun speeds up, sun slows down. Sun speeds up, sun we today call it the equation of time. And we published it, I don't know, all school globes used to have it on the Pacific Ocean. It was a figure 8. How many minutes ahead of clock time, the true time, and how many minutes behind for the calendar. They don't travel in the same time. By this time, we've got clocks having been invented. They've been cumbersome. They haven't been accurate to 30 minutes to 1 hour a day set with a sundial, but they're getting better. And with a pendulum clock coming in, they got way better. How are you going to do it? The sun doesn't tell, and the sundial won't work if you want even hours. You got to correlate clock time, tick, 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 with sun time. Sometimes fast, sometimes slow. And the way you did that was to draw an equation of time on the sundial so you could correct it for clock time. So you'd have, and you'll see those written all the time on that figure 8 on a dial, just like it was on the back of the globe. This coupled with something else that was learned about that time, that if you build a sundial, and this is just a piece of plastic, and you point the gnomon, that's this pointer, straight at the pole star, at the North Star, then these are equal hours instead of the unequal hours. I don't know why it took us this long to figure that out, but it works. And we've been doing it ever since. And that, folks, ushered in the dawn of the age of sundials. They were done everywhere. They put them on buildings, they put them on tombstones, they put them on gardens. This was a golden age of sundials. From about the time the Pilgrims came here until the American Revolution. That's the golden part of it. That's one in Portugal, done in the 1,500 6, 7, 19, IX. 17, 19. Oh, it was in Portugal. But that's the cat. And it was, I don't know if I got a picture or not. Let's see. No. Nope. An educated person was taught how to draw a dial, and then there were graphics for it. And it's just a geometric problem. Lay out angles for the inclination, angles for the hour lines, and it's quite possible to do it. It's tedious, but you do it with software nowadays. And educated people knew how to make sundials, and they made a world of them. They were everywhere. That just happened to be a Portuguese one. Now we're beginning to regulate time much more like a modern society might. Shakespeare got involved. Oh God, methinks it were a happy life to be no better than a homely swain, to sit upon a hill as I do now, to carve out dials quaintly, point by point, thereby to see the minutes, how they run, how many make the hour full complete, how many hours bring about the day, how many days will finish up the year, how many years a mortal man may live. We've made peace with time, sort of. This one's in Jaipur, India, about the same time, 1724. I saw it. I was at Jaipur, and there's a whole series of dials there. In fact, there's two of them here. But that one is something like 90 feet tall. And the shadow that comes down moves about a millimeter each second. So, you know, if you just stand there and look at it for an inch, it's going to be a couple of inches of shadow that's moved. You can literally see, because of the size of it, that the shadow moved. It wasn't really used to tell time because it's too much work to go up and read it. But it was very important to measure angles for calculating eclipses and doing some higher mathematics with it. Clocks kept getting better and better. And it solved the problem of the longitude of a ship by having ship's clocks that were so accurate that within 5 or 6 seconds on a voyage across the Atlantic, that something had to change. Clocks got cheap. American manufacturers turned out a lot of wooden gear clocks at this time. And every farmhouse had a grandfather's clock, or at least my grandfather had a grandfather's clock. And they were set with a noon dial. You didn't have radio. But it's still a society that moves slowly until the telegraph comes in. And then you transmit a telegraph message across the country in a fraction of a second. And the railroads, oh my goodness, the railroads. We got a problem when railroads come in. Because while Albany and New York City and Montreal are within a few seconds or minutes of each other in the north-south, if you go from Boston to Indianapolis, you're talking about 24 plus hours. And it's not going to work if you send a train from Albany over to Boston on Albany time, and the Boston train's coming down that same railroad, around that same curve on Boston time, you're going to have some accidents. And we did. Something had to give. And here we have Saratoga County came to the rescue on that. A fellow by the name of Charles Dowd. Went to Yale, got his PhD, moved here, and opened up a finishing school in Saratoga Springs. And that was his passion to run that school. But he had another one, and that was to solve the standard time zone issue. And he worked on it and made a proposal, and it was successful. As a matter of fact, Isabel Connell, our current president, wrote a very good article on Charles Dowd in one of our more Saratoga County stories books. If you want one, there's some out there. But he made a proposal of how to standardize time. And it was accepted in 1883. And the Eastern Time Zone ran from the East Coast over to 75 East parallel on 60. And then you had the Central Time Zone, Mountain Time Zone, and Pacific Time Zone. And we've been living with those successfully ever since. But things keep getting complicated, folks. We got sundial time, we got solar time, we got clock time, we got railroad time, and we need time even more accurately, so we went to quartz crystal time in the 1920s, and now we're on some sort of atomic time, where things don't vary much. I'll have to go back to that Shakespeare poem. How we just sit there and how long and count the hours. Because it's getting real complicated. And that's understandably so. You can't run satellites on a sundial. Let's look at a few dials that are local. We'll wrap this thing up. That's my garage. And I had to put one up there. There's a blown-up version of it. I have fun making it, setting it up, and it keeps pretty good time. There's one made out of and the fellow that helped us in the room here, made out of a piece of half-inch thick aluminum that we turned down on a lathe in my basement. Thank you, Paul. And I scored it, and it's in Atlanta with my daughter and her husband's house. That's when a sundial doesn't do much good. That's what it looks like when it does some good. That plate is a microwave dish. You know, they put it. I couldn't throw it away. It's just too pretty a piece of glass. And the flange came out of the backyard, but it's labeled, it's stenciled on it for Milton, North Carolina, somebody's mill. This is one of those mills on the K-Ross. And how it got to my house, who knows, but it's being repurposed. Here's what I made in my basement, an armory bit to keep it taut, and then it reads this, and it's got the equation of time down here, and it's got a way of shifting. You move this nut from here to there to change it to daylight savings time. Well, you got to think about these things. There's a little close-up of it. There's one also in the backyard. It's got a curve to it with the hours on it. And then it's got a place that's got January, February, March, April, May, June, October, down the other way. There's that equation of time. And you stand on the day. Well, I'll get you a better picture. There's my wife standing on it. or prototype of it. And her shadow is going to tell you the time. We need one of those at Brookside. That's the way it's laid out, so you can see that. There's a work in progress. There's 3 dials, was one at a 45-degree angle and flat. This dial doesn't, it's probably got noon marked on it, but it doesn't have the hours really. Each day, the shadow of the sun becomes shorter or longer, depending on what season it is. So I have the lines drawn across here for the days that are important to me. And when that sundial shadow gets to that point, to that line, it may be somebody's anniversary, might be a birthday, might be Easter, might be Halloween, and you label them that way. That was fun to do. That one was done for Jimmy Carter Library. It's I think still down there. That's a plywood model of it. Rosalind Carter vetoed it. It's too modern. But this was a model, and I hadn't even finished the model here. And you'll notice that it doesn't line up. We didn't point that gnomon straight to the pole star. We got.
I have a question.
Okay.
I know it's going to sound silly, but so sundials only work when there's sun? So if it's a cloudy day, you can't tell what time it is?
That's correct. Anyway, this one was built for Jimmy Carter Library, which is in Atlanta. And I'm thinking that this was probably in Charlotte, North Carolina, because they are site specific. And Carol, your sundial out there in the corner there is probably not accurate because it wasn't built for your particular garden. Okay, some local dials. This is in Albany, on the City Hall, on the South Tower there. And it was built cast in 1897, and it says the motto on it is "Renew thyself each day." And it's a pretty dial. It's there. You got the latitude and longitude on it, and it keeps pretty good time, I think. That's a postcard from the collection here, I'm told, or at least that's what I thought, of our collection of Saratoga County history. About 1901 or 1902 or something, of a sundial at Yaddo. And you can see the folks that are hanging over it and admiring it and all that kind of stuff. Not long after this postcard, it was stolen. And it sat just minus the sundial there for 80-something years. And somehow or another, renews your faith in miracles. They found the original mold for it in some storage facility and recast it. And I think I might have a picture of it. Nope. That's what it looks like when they recast it. Beautiful. Unfortunately, they didn't put it in the same spot that the first one was. So it's off just a little bit. This one is in Saratoga Springs at the Adirondack Trust. And it's dedicated, somewhere I got the information on that, dedicated to Charles Dowd, the fellow that did the standard time. And it's a pretty dial. It's got all the zodiac signs on it, which if that turns you on, that's fine. It doesn't do much for me. But it tells time remarkably well. And if you're in Saratoga Springs, it's very visible of right behind their bank building. This one is at SPAC. I mean, you go by it, you never see it. I mean, but it's there. Huge. The time is in the sidewalk. There's your gnomon. And you can see where it's casting the shadow here. That thing's 20 feet tall there. Probably just a gorgeous dial. So next time you go to SPAC and the sun's shining, I don't care if the sun's shining or not, you just go look at it because it's pretty. That's a dial in Congress Park. It was put up in 1900. And that's the way it looked. But if you go there now, the gnomon is gone. That treble clef brass gnomon been pilfered, I guess, but it's gone. So it's not a sundial anymore until somebody finds another original mold. We'll rebuild that one too. But that's the way it looks now. It's up in the Italian garden section of Congress Park. And here's one of my favorite dials. This is out of a museum. It's called a noon dial. And folks, this is a magnifying lens. That's the powder hole in the cannon. It's a little bit cannon. And when the sun gets directly overhead, what's it going to do? It's going to shine through there, it's going to shine there, and they go poof! They were real popular in the 18th century. You got to admire somebody to think of something like that. In Sweden, I read just this past week when I was preparing for this, that there is a noon dial built into a building, and they don't use a little toy cannon. They use a regular military cannon. And it sets off every day. Sunshine or not. If the sun doesn't shine, you use a match. And we'll end up, we started out at Stonehenge. This is Manhattan Henge. That's 34th Street. And New York streets are laid out on a grid. They're not exactly north or south, so it won't coincide with the solstice of June 20th. This would have been taken, I want to say Memorial Day. But you get two of them in Manhattan because you got one that's going to line up before it gets to the peak and when it comes back down. So on July 12th at 8:21 in the evening, you'll be able to see that yet again. Folks, I like sundials. And I like talking about them. And I like the idea that you can create something that just gives a lot of joy to a lot of folks. That's my story, and I'm sticking to it. Thank you. Yes, sir. Yeah.
You say that you align sundial with the North Star, Northern Hemisphere. What do they do in the Southern Hemisphere?
There is a star that they can use. Actually, you got to triangulate off more than one star to get to the exact spot. But they have a star. I should know, but I don't remember because I'm so seldom in the Southern Hemisphere. But good point. They have to have something to point to as well.
Yeah, I think there's a constellation in the southern hemisphere that's called the Southern Cross.
There is a Southern Cross.
And I think it's the center of that to be on that. I'm
Yeah.
not sure.
Somebody do the Google on it. Anybody else? Gosh, you'll let me off easy. Yes, ma'am.
You have a picture of Stonehenge. Does that have anything to do with sundials at all?
If you say that the summer solstice is a period of time, June 21st, then yes, you know that sun is telling you when it's highest and when the summer starts. It used to be that you needed to know the solstices to calculate when you should plant in ancient societies. The Egyptians got lucky because they had the Nile. There was pretty regular flooding there, but everybody else had to know when the equinox came between the solstices. That's the time you started planting. Yes, sir.
Would you speculate on the future of time? If we're measuring it by atomics now, is there something that's going to change in the future?
Einstein said it better than I'll ever say it, but yes. Time has gotten to be extraordinarily complex. The closer you go to the center of the earth with more gravity, and I'm on the periphery of what I can talk about, the slower it gets. The whole earth is slowing down in its spinning. 1 second every 25,000 years or something. We are constantly having to adjust, and now they'll set atomic clocks up 1 second every 2 or 3 years in order to keep everything that's circling around us in satellites uniform. But time is changing, and we're having to change with it.
As we come to be on other planets like the moon and all that, how are we going to manage time up there?
There was something in the paper the other day about having a different clock for the moon. It has a different cycle. All righty.